Okay, Engineering 10. Today we're going to learn about the transistor, without which you would not have your phones that distract you and provide so many amazing opportunities and learning opportunities and relaxation opportunities and distraction opportunities and entertainment opportunities. Without the transistor, you wouldn't have that. Without the transistor, you wouldn't have TV or radio, the interweb. You wouldn't have any of the technology that we have. So to say that the transistor is a life-changing invention is pretty accurate, I would say. So what we're going to learn about today is how to use them, what they're used for, how to use them, and how to work their magic. The materials you're going to use. So we are going to be building probably the most complicated circuit you've yet built in Engineering 10. You're going to need a breadboard. You're going to need an LED, a functional LED, so make sure that you're not using a blown one. You're going to need 3 resistors, approximately, and I should have plenty of these, so 180 ohm, 10K ohm, and 680 ohm resistors. So you should have 3 of them. And you should have a push-button switch. You should have a transistor. We're going to be using the 2N2222 transistor, and if you haven't seen my other video on It's All About the Bass, then you should watch that. But the transistor, the 2N2222, and if you can say it as quickly as I can, then more power to you. That's the transistor we're going to be using. There are lots of different types of transistors, but that's the one that we're going to begin with. And then you'll use a multimeter later on in the lab. So if you look in your little dime bag that I've given you with all the components that you need for your final summative project, you should see a transistor in there, and it will either look like a little tin can with a little tab on it, or a plastic 3-legged thing. The tin can is the one that I like the best. That's the one that if I have the choice, the option of buying, those are the ones that I buy. Just somehow metal seems a little bit more sturdily made, better made than plastic, although they are exactly the same form factor. The legs are exactly the same pinout. But the transistor, the 2N2222, is the one that you've got in your hands, and it is the most widely used semiconductor of all time. It was introduced way back in 1962 by Motorola, still in production and still in use today. Now, if you take a look at the legs, there are 3 legs, and remember how every time that I've given you a 3-legged component, I talk about the middle leg, the middle one being the most important, or maybe not the most important, but it means something. Well, no exception here with the transistor, because the middle one is the base, and it's all about the base. So the other 2 are the collector and the emitter. And the key thing is to figure out which one is which. So if you have what you likely have in front of you, which is the tin can, if you check it out with eagle eyes, with really, really good vision, or feel with your finger around the edge of the can part, the round part, you should feel or see a little tab. It kind of sticks out. And that is going to be how you identify which leg is which. And they matter. So the leg that is closest to that little tab is the emitter, the E. So the emitter sends out the current. Okay, so if a current is flowing through a circuit, this has got to be on the negative side, the ground side of the circuit, because that's where the current is getting sent out. The emitter emits. If you look at the underside of your transistor, you'll see that the 3 legs are kind of on one half of the circle. And so if you count around the circle, the leg that's closest to the tab is the emitter, the middle one is the base, and the one that's farthest away from the tab is the collector. The collector collects, it receives the current. The emitter emits, it sends out the current, and the base, well, it's all about the base, and the base controls it all. So pay attention to which leg is which, because that's crucial to being able to build this circuit. This is the circuit there. Oh yeah, this is the next tab, the next slide, and I forgot that I've got a duplicate here essentially. Now, if you do happen to have one of the plastic ones, you just need to feel around the circle because it's kind of a half circle, and there'll be a flat side. If you're facing the flat side, then the tab, the leg on your left is the emitter, the leg on your right is the collector, and the one in the middle is the base. Okay, so you're going to build this circuit, and this circuit is the most complicated one you have yet built. So pause this video, make sure that you get it working correctly. But what you're going to, the key thing here is to make sure that that your transistor is in correctly. Now, in this image, it's got an image of the little plastic one. Even if you have one of the tin can ones or the little metal can ones, then you still need to build it the same way. So identify which one is the collector, which one is the emitter, and which one is the base. In this picture, we're looking at it. So the leg on the right is the emitter. That's the one that emits. And you can see that the current is coming out of there, going through a resistor to an LED, in the anode, out the cathode, and over to ground. The collector is the one at the leg on the left. That's the one that's connected to another resistor that's coming straight from power. And then the base, well, the base is the one that controls it all. And that is connected to the resistor, the 10K ohm resistor that goes over to the button. And then the other side of the button is connected to power. So pause this video, make sure that you can actually build that circuit. If you have your circuit built correctly, it'll look something like this. Hopefully this doesn't all fall apart. And, oh, it just did. Ground cable just fell out, so let me put that back in. There we go. Now my power just fell out. And there we go. Stay. Now, this doesn't look like a very important, impressive circuit, frankly. But if I push the button, the LED turns on. Now, that's not that cool. We've already built a circuit like this where we push a button and the LED comes on. And that circuit was way easier than this. So what's up with this? Okay, I'll give you a few minutes to study this circuit and see if you can figure out what makes this work, because this is pretty sick. Hopefully you were successful in getting your circuit working, and it worked something like mine. If you have not yet been successful, make sure that you figure this out. This is really, really important. So go back and check all your connections. Make sure your LED is plugged in the right way, with the anode getting the positive side of the circuit, connected to the positive side of the circuit, and the cathode connected to the negative side of the circuit. Make sure that the collector is also is on the positive side, so it's coming in from the 180 ohm resistor. And the emitter is on the negative side of the circuit. So that's at the 680 ohm resistor that's going over to the LED. And then the base, remember that the base is the one that is connected to the 10,000 ohm resistor that's going over to the button. So make sure that you've got that set up properly. If you don't, pause this video and try it again. Okay, now that you've got your circuit working, take a look at it and be impressed by it. Because if you're not understanding what's happening here, then it's not that impressive, because you know you've built a circuit where you can push a button and turn an LED on in a way simpler fashion, way simpler circuit. We've done it before with just a button, a resistor, I think we used a 330 or a 220, and an LED. And doing that circuit can have the same effect as this. But if you're a thinking person, if you're understanding how electricity is flowing through a circuit, then this does not make sense. The results of it are quite simple. When you push the button, the LED comes on. But think about it. Look at your circuit. Do a little bit of math. How is this possible? Here is a schematic. It's a different looking schematic than what we've mostly done in class, but it kind of gives you a good indication of how this is happening. So you should be able to identify all the components in our circuit here. We've got our push button switch here. We've got our 2N222 transistor, and we've got an LED. And in between, we've got a whole series of resistors. R1 is a 180 ohm resistor. R3 is a 680 ohm resistor. And R2 is a 10K or 10,000 ohm resistor. And so what's happening here is that the current, if we think about current flowing from positive to ground, and I know I keep on saying that we know electrons flow in the opposite direction, but if we're talking about the current or the energy, we're flowing through 180 ohm resistor. We hit the collector, we hit the emitter through a 680 ohm resistor, and that's not enough to turn the LED on. But then we push the button and we give the current an alternate path to follow through 10,000 ohms of resistance, and suddenly the LED turns on. How is that possible? 180 plus 680, that's 860 ohms of resistance. So we've got 860 ohms of resistance, and the LED is dark. We give it a path to follow 10,000 ohms of resistance, and the LED comes on. How is that possible if electrons follow the path of least resistance? Path of least resistance is clearly 860. 860 is less than 10,000. So what's going on here? So here's the explanation. There are two paths. We've built a parallel circuit here. On the one path, you've got this going through without the switch, you've got it going through the 180, the 680, so 860 ohms of resistance, and nothing's happening. But notice that there's really this little bit that's going to the base of the transistor. It is not actually getting any current here. It doesn't get current until the button gets pushed, and we send another alternative path through 10,000 ohms of resistance, which is enough to touch to just give a little tiny trickle. I like to say it tickles the transistor. It applies a little bit of current to the base, and that is where all the magic happens. That tells the transistor to close, like it's essentially got a solid state switch inside that makes a connection between the collector and the emitter, and then that little tiny bit of current is enough to make the connection between the collector and the emitter, and that allows the LED to glow brightly. So it's a pretty impressive little switch. This is essentially an automated switch. So up until this point, we've had manual switches where you need to push a button in order to make a connection between two sides. This is a type of switch where you don't need to push a button. You just need to give it a little tiny bit of current, and it automatically makes a connection between the collector and the emitter. So with that little tiny bit of current that's getting through the 10,000 ohm resistor, that's enough to make the connection between the collector and the emitter, and the LED glows brightly, or glows, hopefully not blows, glows brightly. Okay, now, if you're wanting to check out what's going on here, you're more than welcome to grab your multimeter, set it to measure volts DC, and check the voltage at the different points in the circuit. So I put the negative probe on from the meter touching the negative voltage source, like right up to the ground rail in your breadboard. And touch the positive probe to the top pin, the middle pin, the collector, the emitter, and the base of your transistor. And when you push the button, you should see the voltage change. Okay, now that we know how this circuit is working, and that the transistor is working some crazy dark magic when it comes to allowing electrons, a little tiny bit of current to allow a solid state switch to connect the collector and the emitter, then let's take it to another level. So right now we've got a 10,000 ohm resistor. Remember when we tried to measure the resistance of ourselves? Well, let's insert ourselves into the circuit. So, remove R2 and the push button. So essentially what you're going to have hanging off the breadboard are two wires like this. So you're going to remove the push button and the 10,000 ohm resistor, that connected the button to the base of the collector. So pull those out of your circuit. And so now what you're going to have is that one wire that ran from power to the button. You're going to have that one wire hanging off your breadboard, and put in a new wire. So take out the 10K ohm resistor that connected the other side of the button to the base of the transistor, and connect a wire to that same base of the connector, to that same row in your breadboard, to connect to the base of the resistor. Once you've done that, your circuit should look something like this. Notice that I no longer have my button in there, and I no longer have the 10K ohm resistor in there. This is the wire that connected to my button, and then I've added another wire over here that connects, it's into the same row as the base of my transistor. Not sure if you can see that or not. But this wire is in the same row as the base of my transistor, and this wire is just into power. Once you're ready, what you're going to do is touch the tip of your finger to the two wires. And what happens? Oh my gosh, the LED lights up. Now, a little bit of warning here, you shouldn't use two hands. Fingertip switching is safe because the electricity just passes through your finger, a little tiny bit of flesh in your finger. You won't even feel it, but it's not a good idea to put the finger of one hand on one wire and the finger of your other hand on the other wire. That allows the electricity to pass right through your body, and the chances of hurting yourself with this voltage and amperage are extremely small, but generally speaking, you should not allow electricity to run through your heart. Okay? Now, that being said, I have never had anybody hurt themselves, because in fact, what we have done is maybe a little bit off kilter here, but we have all held hands in class and seen how many people we can add to a daisy chain. So the first person in the chain holding on to the first wire, all the way around the classroom holding hands, singing Kumbaya together, and then the last person in the daisy chain can hold onto the other wire and see if that LED lights up. Now, warning. I just gave you this warning. Don't use two hands. That means you're using both hands. If you have any kind of a heart condition, you don't want to do this. Now, it's an extremely small amount of current, so I'm quite convinced that it's not going to hurt anybody, but that is a warning, and do not feel any obligation to do this whatsoever. But if you feel like taking a little bit of a risk, then you can actually get together, hold hands, first person in the daisy chain hold onto the one wire, last person in the daisy chain hold onto the other wire. Okay, and assuming that this is working properly, here's what you should have happen. I'm going to touch both with my fingers and check it out. The LED glows brightly. Release them, LED's off, touch them again, there we go. Pretty crazy, huh? So, what we've just demonstrated here is that our really, really high resistance bodies still allow enough current to run through us to get a tiny, tiny bit of current onto the base of the transistor, and that's enough to make the solid state connection between the collector and the emitter. Wow. Now, obviously, if you lick your fingers, so touch the tip of your finger to the two wires, then your LED will light up. If you lick your fingers, then you should, well, probably by this point you'll know what's supposed to happen there. The LED should glow a little bit more brightly if you do that. So what the heck happened? Your finger is conducting enough voltage, even though you're a pretty big resistor, as we discovered in the resistance lab. You provide a lot of resistance through your body, but it's still enough to get enough current to the transistor. So even though your skin has a high resistance, the transistor still responds. It isn't just switching the LED on and off, it's actually, a lot of people call a transistor an amplifier because it's amplifying the current applied to its base. Tiny, tiny trickle of current got to the base, but that amplifies it by providing enough current to get through to the LED to light up. So not only do transistors act as switches, they also amplify any change in current that you apply to their base. So that's the lab. Now, a few points to hammer home here. A transistor is a semiconductor. That means that sometimes it conducts electricity and sometimes it doesn't. Its internal resistance varies depending on the power that you apply to its base. So NPN transistors are activated by positive voltage on the base relative to the emitter. That's what we were just using. The 2N222 is an NPN transistor. There are also PNP transistors that are activated the opposite way by negative voltage applied to the base relative to the emitter. But in their passive state, both of them block the flow of electricity between the collector and the emitter. So if nothing's being applied to the base, the current from the collector does not get through to the emitter, or at least there might be a tiny little leak of it, but not enough to actually do any real work. So you may think of a bipolar transistor as if it contains a little tiny button like the buttons we've used in class inside. When the button's pushed, it allows a large current to flow. To press the button in a transistor, all you do is you inject a tiny amount of current onto the base by applying a small voltage to that base. Okay? So to start the flow of current from the collector to the emitter, apply a relatively positive voltage to the base. In the schematic symbol, the arrow points from the base to the emitter and shows the direction of the positive current. So here's your collector, here's your emitter, here's your base, and the little arrow shows the connection or the direction of the flow through the transistor. Now, in the 2N2222, the base must be at least 0.6 volts more positive than the emitter to start the flow. The collector also must be more positive than the emitter. Never apply a power supply directly across a transistor, it'll likely burn it out. You always want to protect a transistor with a resistor. The transistors are probably the most expensive components that you're going to be using in your circuits, so make sure that you protect them. Avoid reversing the connection between the positive and negative voltages. You can actually burn yourselves with them. If you plug in one of these 2N222s backwards, you'll wreck them, and they'll actually put off quite a bit of heat. So it's not like you're going to give yourself a third-degree burn or anything like that, but it can be enough to melt some of the holes in the breadboard and smell very unpleasant. And that is the end of the transistors lab. So the transistors, the most important invention since sliced bread.